Hey guys, it's Mr. Morrissey again. Today we're looking at the quadratic formula and the discriminant. You can see the objective says solve quadratic equations by the quadratic formula, which we just proved last class. Recognize when the quadratic formula gives complex solutions and write those solutions in a plus bi form for real numbers a and b. We'll practice that latter part there in number 3. And yeah, let's get right to it. Okay, this first equation we can definitely factor just to get an idea of what the answer is, and then we'll do the quadratic formula. So here, just do this real quick. 6 times 2 is 12. 6 plus 2 is 8. X is negative 6 or negative 2. Let's use the quadratic formula. A is 1. There's an invisible 1 there. We need to know that. B is 8. C is 12. B squared is 64. There's me plugging into the quadratic formula. 4 times 12 is 48. Difference in here is going to be 16 over 2. I guess it would probably be best to write x equals, so we know exactly what we're solving for. Square root of 16 is 4. So let's break this into 2 parts. Okay? There's part 1. There's part 2. Negative 12 over 2 is negative 6. Negative 8 plus 4 is negative 4. Over 2 is negative 2. And I think we would agree those are the 2 answers there. Remember from our graphing from earlier in this unit, this would mean, just a little rough sketch, this is going to be a sketch. Negative 6, negative 2. Since this is a 1x, the graph is upward facing. The y-intercept is 12. Here's a rough sketch. I won't even find the vertex, but there's a rough idea of what the graph looks like. But we weren't even asked to do that. Keep going. So we just solved the quadratic equation using the quadratic formula. That's the key skill for today. Okay, we have this idea of the discriminant. Take a look at the front page of the notes and pause right now. So with the discriminant, it says we want one distinct root. Well, what that means is b squared minus 4ac will be 0. To show you what it means graphically, it would mean something like this. The graph is going to touch the x-axis in one point only. It'll be tangent graph to x-axis if discriminant is 0. So let's see. b squared minus 4ac. Whoops. Make sure this is okay. Okay. So negative 5 squared we want that to be true. We have to solve for a. If we solve this equation for a, negative 5 squared minus 4 times a times 9 equals 0. So the value for a, that will give us one distinct root, meaning a double root. I should write that down. We've already done this before, but I'm just going to reinforce. Would be a equals 25 over 36. Okay, we're going to practice this again right now. Remember guys, you can always stop it. Let's see, how many solutions does 3t squared minus 18t plus 27 equals 0 have? Find them and sketch a graph labeling all intercepts. Okay, let's do that part first, and then we'll do the second part. First thing I'm going to notice here is I can factor out a 3. That would be important to recognize. Otherwise, your math is going to get really hard. So this factors very nicely. So 3 times t minus 3 squared. This is just a parabola shifted over to the right 3 units. You call it, say, equal to y. It's going to look like this. 1, 2, 3. Tangent to the x-axis, going up. And this intercept here will be at, so y-intercept, that's f of 0, plugging in 0 into the function. If we had said this is f of x equals, or in this case f of t. So if I have f of t equals 3t squared minus 18t plus 27, f of 0, this is 0, this is 0, the answer is 27. The y-intercept would be 27. There's my graph. How many solutions? There's one solution. One solution, it's x equals 3. And look, that must mean that the discriminant must have been 0. Let's make sure that it was. So let's see. Let's take this equation right here. Okay. So b squared (18 squared minus 4 times a times c). Now 18 squared, 18 is 9 times 9 times 2 times 2. Notice 18 is 9 times 2. Square it, you get 2 of them. Minus, I'm trying to do this without a calculator. So if I had a calculator, you'd see that this is 0. 4 is 2 times 2. 3 is by itself. And 27 is 3 times 3 times 3. These two 9s here are 3 times 3. You notice 18 squared is 9 times 9 times 2 times 2. 9 is 3 times 3. This 9 is 3 times 3 times 2 times 2. Subtracting 4 times 3 times 27 is the same. They're the same number. That gives you 0. So that shows you that the discriminant was 0. That tells you, by definition, there's only one solution. The solution was x equals 3. Then, part 2 says, then sketch a graph of x minus 3 squared plus 1. Okay. So this is something we've done in the past, graphing in vertex form. The vertex moves over to the right 3 and up 1. Since there's an invisible positive 1 in front of those parentheses, the graph is going to shift up, or go up. Here you can see very clearly that there's no solution here. There's no place where the graph crosses the x-axis. Let's make sure that we can see that that's true. We're going to take this equation, we're going to expand out, combine. Here's my equation. If I was to plug into the if I was to plug into the quadratic formula, you'd get, so I'm going to need some room here, so I'm going to come over here. 6 plus or minus, so b squared is 36, a is 1, so this 36 minus 40 is negative 4. Here's our friend, the imaginary number. The square root of 4 is 2, and with the square root of a negative number you get I. So 6 plus or minus 2i over 2. So now we're going to simplify. 2 goes into 6 3 times. 2 goes into 2 1 time. We get 3 plus or minus I. So 3 plus or minus I gives you a complex solution. So 3 plus or minus I are the two roots. They're non-real roots. So complex roots. And you would know that from the beginning because this parabola has been shifted up and does not touch the x-axis. Alright, this seems like a good place to stop. We'll go on to the last two questions in part 2. Bye, guys.